Good day, guys. All right, so in this video, I want to talk about potentiometer. Um, Meter means to measure something. Potential just means potential. You are measuring potential differences, much like a voltmeter, but a little bit different. Because in this case, instead of having a voltmeter, you have a galvanometer. A galvanometer is much like a voltmeter. Difference is it will tell you which direction. So if you look at the dial, or at least the screen on the galvanometer, it will start from the middle, 0, and then it will range, so from negative V to positive V. It will start from here. It will start from here and then go left or right depending on the orientation of your current. All right, voltmeter, it doesn't do that. Voltmeter it only goes from 0 to some positive value. Now, if you look at the circuit, right, it's much like the potential divider. Difference is there's an extra power supply. Okay, so let's look at the principle behind this potentiometer. All right, so this potentiometer is is checking whether or not the voltages are the same. In other words, the galvanometer will show a 0 reading when epsilon 2 is equal to the voltage across, let's call this A and this to be B. All right, that is the potential difference between A and B. Okay, when they are equal, galvanometer will be 0. I mean, it will show a 0 reading. Okay, so the application here is that you can use to find out unknown values or unknown potential difference created by an unknown EMF. So how do we do that? Well, first we find that we do know. So let's have epsilon 2. Maybe we have 2 volts, 3 volts, one that we do know the value. Again, let me just remind you, galvanometer will show a 0 reading when the EMF supply, so E2, this one, is equal to the potential difference between, let's again call this A and B. A and B. All right. So here we have, if we use Ohm's law, we have I R A B. Okay, this is just Ohm's law. Ohm. Now we have another equation that we have just learned, which is resistivity, right? So resistance is equal to resistivity times length over the cross-sectional area. We're going to assume for the wire, the whole thing is made out of the same material and has the same cross-sectional area. So I can put those as just constants. So the length here, so if I put RAB, if I say RAB, it is merely rho over A because they're constants, and then LAB. Okay, in that sense, I can have epsilon 2 is equal to I rho over A and then length between A and B. Okay, now let's take that battery out, or the power supply or EMF. Let's take it out, and then what we do is we replace it with something else, right? Okay, there we go. Now at this point, the galvanometer shows it is 0 when it is between point A and C. Okay, so again, I will write it down there. Okay, epsilon 3 is equal to VAC, and that is equal to IRAC. Okay, and this RAC is equal to rho over L between A and C, the length between A and C. Okay, again, I will expand this. I will put down there epsilon as epsilon 3 is equals to I RAC, which is equals to I rho over A. Rho means resistivity. Again, just to remind you, LAC. So this is epsilon 3. Now let's have a look what we have. We first have, I'm going to use blue. We first have epsilon 2, which is the known one, right? The known one, I have I rho over A, L A B. And then I have the second one. I'm just going to use yellow. epsilon 3 is equal to I rho over A. We're using the same wire, right? And then we have the same power supply for E1, epsilon 1. So we have the same current. And we have LAC. Now, in order to figure out what epsilon 3 is, which is the unknown, we can relate them. We can take the ratios between them. I personally, I would take epsilon 3 over epsilon 2, right? And that would give us, let's just expand that, I rho over A top LAC over I rho over A LAB. I can cancel those out, and what I have at the end is epsilon 3 is equal to epsilon 2 LAC over LAB. So we have just figured out, right, the unknown EMF, which is this one, unknown, unknown. By using a known EMF and looking at where they fall, or the galvanometer gives a 0 reading. Okay, so that is all. I'll see you in the next video.